In this video, you will find Ix for the given circuit using the nodal analysis. This is the given circuit, and if you see input, it is 20 cos of 40. So it is AC signal. So that we need to solve this one in the phasor domain representation. So now everything we have to write in phasors. Like for example, 20 cos of 40 is there. How to write this one in the phasor representation? 20 at an angle of 0. Here the frequency omega is equal to 4. Okay. Then 10 ohms will be 10 only. Then 0.1 farad is there. It is capacitor. So capacitance value is equal to 0.1 is there. So its phasor domain impedance will be 1 by j omega c. 1 by j omega is 4 and capacitance value is 0.1, that is equal to 1 by j means minus j we can write. It is 10 by 4, that is equal to minus j 2.5. Okay, like that we can able to write. And then we need to concentrate on next 1 Henry is there. Inductance is equal to 1 Henry. Its impedance is given by j omega L. J into omega is 4 and inductance value is 1. That means it is simply J4. Next again one more inductance is there, that is 0.5 Henry. So for this one j omega L, that is equal to j into omega is 4 and 0.5 Henry, that is equal to J2. Okay, so like this we have to calculate whatever the required things are there, all those things we have to calculate in the given circuit. And here one more important point is we don't know what is Ix. Ix is the current which is passing through this capacitor. Okay, that is the current that was missed in the given question. Now we need to redraw the diagram. So using all these values. So source is 20 at an angle of 0. Resistance no change. Capacitor is having the impedance of minus j 2.5, and through this one only current Ix is passing. And then here one inductor is there of value 1 Henry. Its equivalent impedance will be J4 in the phasor domain. Then here dependent current source is there with value 2 times of Ix. Then one parallel inductance is available of value 0.5. Its related impedance in the phasor domain is J2. So we have written the diagram in the phasor domain. This is the main step. Then we need to calculate Vx, and by seeing the diagram we can easily tell that it is one principal node, it is another principal node, and it is the ground. So we'll take the first principal node is 1, second principal node is 2, and we'll assign the voltage like V1 and V2. And rest of the thing is same. How we have done for the previous circuits, in a similar manner we have to perform the nodal analysis. Okay, so if you apply KCL at node 1, what will you get? V1 minus 20 at an angle of 0 by 10. This is the leaving current through 10 ohms, and then plus V1 by minus j 2.5. This is the current through the capacitor. And one more thing, here we have to write this controlled variable. It is Ix. So Ix is equal to current passing through that one. That is V1 by minus j 2.5. Controlled variable we have written in the node voltages. Then coming to another branch that is J4. So it is the branch available in between the two nodes 1 and 2. So the current through that one will be V1 minus V2 by J4 is equal to 0. It is the KCL related to node 1. Now we'll take KCL at node 2. Okay, that is V2 minus V1 by J4. This is the amount of current passing through this J4. Okay, then plus here 2 times of Ix is entering into the node. I need to make it live, for that minus 2 times of Ix. What is Ix? V1 by minus j 2.5. So then Another branch is there, that is J2. So through that one, the leaving current will be V2 by J2 is equal to 0. So it is equation 1, it is equation 2. These two equations are available with the two unknowns, that is V1 and V2. So simply you have to solve them. Okay. So, by arranging these two equations, we will modify like this. Okay. So by solving these two equations, you will get V1 is equal to 18.97 at an angle of 18.43 degrees, and V2 is equal to 13.91 at an angle of 198.3 degrees. But what we need actually we need Ix. So Ix is the current passing through the capacitor minus J2.5 impedance is available for that particular capacitor. So Ix is equal to, you can able to write V1 by minus J 2.5 minus J 2.5. So it is equal to V1, already we got 18.97 at an angle of 18.43 by minus J 2.5. Okay, and numerator is in the polar form, denominator is in the rectangular form. You can treat this one like 0 minus this one. So write this denominator also in the polar form. Okay, then what will you get? 18.97 at an angle of 18.43 by it. This will be 2.5 at an angle of minus j means minus 90. You will get it is equal to 7.59 at an angle of 108.4 degrees. Okay, now if you want to write this one in the time domain representation with 7.59 peak value, cos of what is the frequency 4, so that 40 plus 108.4 degrees. This is the way of writing this particular current. Thank you.